All right, guys, in this video, we're going to go over the graph of the parent function for cotangent. So it says, using your unit circle and your knowledge that cotangent is equal to 1 over tan of x, graph y equals cotan of x on the interval negative 2 pi less than or equal to x less than or equal to 2 pi. Then identify the domain, range, asymptotes, period, increasing slash decreasing intervals, and if the function is even or odd. So I'm also going to write that cotan true is equal to 1 over tan, but cotan of x is also equal to cosine over sine, right? Because if it's the reciprocal of tangent, and tangent, as we recall from the previous slide, was sine over cosine because it's y over x. Then if we did x over y, it would be cosine over sine. Okay, so I'm just going to do a quick sketch of the unit circle again and the key unit circle values that we're going to look at for cotan. All right, so I sketched the unit circle values, right? So if we recall, at 0, pi over 2 pi, 3 pi over 2, and 2 pi, right? Those are the where we lie on either the x or y axis here. So let's kind of reconstruct it for cotan, okay? So for cotan of 0, okay, x cotan of x at 0, if we did cosine over sine, right? So remember, it's x over, is essentially the x coordinate over the y. It would be 1 over 0. So it would be undefined at x equals 0. So we're actually going to have a vertical asymptote on the y-axis there at x equals 0. At pi over 2, we would have, again, x over y, so it's going to be 0 over 1, so it's going to be 0. And then at pi, if we do x over y, it's going to be negative 1 over 0, so it's also going to be undefined there. So that means we're actually going to have a vertical asymptote at pi radians. Pi over 2, we're at 0. And if we were to do the reciprocal, right, so if you think about that cotan is the reciprocal of tangent, the reciprocal of 1 at pi over 4, the reciprocal of 1 is still 1. So what I'm going to do is I'm going to put a tick mark here. Pi over 4, we would be at 1. And then at 3 pi over 4, the reciprocal of negative 1 is still going to be negative 1. So 3 pi over 4 here will have negative 1 as that coordinate. Okay, so if you were to graph cotan, okay, on your calculator, you'll see that right now, if we just looked at it, it looks like that it's kind of looks like a linear function in between the two vertical asymptotes here on the left and the right. But you'll see if we were to graph it, it's actually going to be a kind of looks like a cubic function, but reflected over the x-axis, right? And so instead of it increasing like this, it's a backwards, I call it backwards Saturday Night Fever, right? So, and if we were to continue with the filling in the values to 2 pi, right, we would go, we know that at 2 pi, it would be undefined as well. 3 pi over 2, it's going to be 0, because again, 0 over negative 1. At 5 pi over 4, we'll be at 1. And at 7 pi over 4, 7 pi over 4 will be at negative 1. So those are, so what's happening here is that from 0 to pi, or from pi to 2 pi, that's technically one period of cotan. All right, so I'll kind of bracket that off there. So here we go. This is, let me zoom in. That is technically one period. Okay. And zoom out a little bit. We can go the same way in the opposite direction. So if we go 2 pi radians to the left and pi radians to the left, we're going to see kind of like the same type of pattern. Now I'm just going to do a quick sketch because we kind of know what the general shape of it's going to be. It's going to be backward Saturday Night Fever in between our intervals, okay? So the domain for this function, it's all real numbers except x cannot equal n pi, right? So every pi radians, there's going to be a vertical asymptote. So 0 pi, 1 pi, 2 pi, 3 pi, for again, the parent function of cotan. The range is technically all real numbers, right? It's going from negative infinity to infinity. Because the backwards Saturday Night Fever is going up to infinity on the left side and then down to negative infinity on the right side. Our asymptotes occur where the domain is undefined. There's going to be vertical asymptotes for every n pi radians. The period we saw, similar to our tangent function, all right, we can use the period, and I'll write a note here that the scale, just like with the sine and cosine, you just take your period and divide it by 4. Okay. You can do the same thing here. I'll add that note here. All right, so I just added that note here for the tangent function as well. Okay. Period is, sorry, the scale on the x-axis is the period divided by 4, just like with the sine and cosine functions. Okay. This function here is technically decreasing, always decreasing when it's defined. Okay. Just gonna double underline that here, and again, whenever that function is defined. And then to check whether or not the function is even or odd, this function is still technically an odd function. There's symmetry about the origin. And the way we could tell is again, if we have x, y, so I'll use this here, pi over 4, 1. We have negative pi over 4, negative 1 for that coordinate there to show that it's going to be there's going to be odd symmetry. All right, so I finished writing it in there, and we're using C graph for example coordinate Okay, so that is our characteristics for the cotan function.